Good afternoon, everyone. We're going to be talking about pollution trends and U.S. environmental policy, lessons from the last half century. We have Joseph Shapiro here to tell us about this, so you have the floor.
Thanks very much. Sorry I can't join you in person. I have to teach here in Berkeley, so I'm spanning coasts. I'm going to describe some research that others and I have done on environmental quality and policy over the last half century. The setting is, if you go back to the 1960s, concern about environment in the US started to rapidly increase. There were several reasons. Rachel Carson wrote this powerful book on how pesticides and toxic synthetic chemicals might be affecting human health and the environment. It was the first photo of Earth taken from space. People called it Earthrise, and it led to this communal feeling that our planet was very fragile. We just have one, we've got to take care of it. There was a serious oil spill off the coast of Santa Barbara, California. There was a fire on the Cuyahoga River in Cleveland, and then a Time magazine article about it, which many politicians in the 1970s cited that photo and article as really changing their opinion and making them think industrialization had gone too far. One side note on that is that the Cuyahoga River in Cleveland, it actually lit on fire every decade from 1870 through the 1960s. And the 1969 fire in the Cuyahoga was one of the smallest that ever happened, but it just came at a time when there was already concern about the environment. And finally, this group wrote a report called Limits to Growth, which projected what the environment in the US would look like. And it had these cataclysmic projections, but that by the end of the 20th century, pollution would increase exponentially and cities would be uninhabitable. And fortunately, that turned out to be wrong. That's not what happened. And one potential reason is that, spurred on by those concerns in the 1960s, there was a lot of policy changes in the 1970s to protect the environment in the US. First, Congress created the Environmental Protection Agency. Then Congress passed the Clean Air Act, the Clean Water Act, Safe Drinking Water Act, the National Environmental Policy Act. Those all happened in the early 1970s. So it's now a half century later. I was actually talking to my kids about this morning, and they were like, were you alive when this happened? So their conjecture was that I know about this from when I was in negative ages, so I was not alive when this happened. Nonetheless, I've learned a lot about it by looking retrospectively at data. So I'm going to propose 4 hypotheses to describe what's happened to the US environment and environmental policy in the last half century. The first is that air pollution, drinking water pollution, and river and lake pollution have gone down, but greenhouse gases have increased. The second hypothesis, why has this happened? It's that environmental policy is the main reason. It's not outsourcing dirty production to low-income countries. It's not technological innovation, it's environmental policy. The third hypothesis is that most of these policies for air and drinking water pollution have created large benefits that substantially exceed their costs. For policies to clean up pollution in rivers and lakes, it's less clear how the benefits and costs compare. The fourth hypothesis I'm going to talk about is that there's been recent controversy when people have compared environmental standards against market-based environmental policies like cap and trade markets and pollution taxes. And a growing concern is that the market-based policies are bad for environmental inequality, that they lead to adverse outcomes for low-income communities and communities of color. And I'll summarize a number of studies which tentatively suggest the effects of environmental standards, sometimes called command and control, versus the effects of market-based policies like cap and trade markets and pollution taxes are not dramatically different. They don't have dramatically different distributions of environmental damages. Most of the next hour, I'm going to talk about these 4. I'm calling them hypotheses, so I'm using H, not T. They're not a thesis. I'm not going to call these a theorem, which are true. I think the evidence for the first hypothesis is the strongest. The evidence for the fourth hypothesis is the most limited, but there's emerging evidence for all of them, and I wanted to try to summarize this. By the way, just in terms of management, I'm going to leave 10 minutes at the end for questions and discussion, but I really welcome questions anytime during the hour. Feel free to just chat, ask, share comments. I'm very flexible. As I go along, I'm also going to highlight some advances that have allowed analysis and research to make progress on the kind of classic questions I'm going to talk about. One is that many environmental domains collect data in order to manage programs. Those are called administrative data. increasingly researchers are able to use those data to evaluate and assess the programs, even though that was not the intent of these data, they were created for management purposes. A second advance is that in many settings, it is now possible to measure benefits and costs and equality from a single setting with a single program, obtaining standard errors and confidence intervals. In the past, often people had to appeal to external validity. They would take an estimate of benefits in one setting and an estimate of costs in completely different settings and try to argue that they were comparable. A third advance is that there are many central components of major environmental laws, which until quite recently have not been a focus of research, and those understudied policies, we're starting to learn more about them. A fourth advance, which has made it more possible to answer these questions, is that scientists and engineers have created more sophisticated models of pollution transport. Those models tell you if a power plant in a specific place is emitting pollution, what is the effect of those emissions on ambient environmental quality in all communities? So how does pollution move through the air and through rivers and through drinking water systems? A fifth advance is that it is increasingly possible to use microdata on individual households and power plants and firms, and then find ways to aggregate that up to obtain a macro picture of the environment in the entire country and the entire economy. And finally, until probably the last decade, the focus of environmental economic analysis was on the average or overall level in the economy. And increasingly, because of interest and data and analytical tools, it's possible to look at the distribution of environmental quality to see how these policies affect well-being in rich and poor and black and white and many different kinds of communities. And overall, the goal of what I'm presenting here today is to try to see what we can learn from taking a very broad picture of looking at many pollutants, many laws, many studies, and many years, and to frame a research agenda which is growing in environmental economics. I will say this presentation is building off a paper I published with this title last year. I wrote that paper because a conference of environmental economists asked me to give a keynote address summarizing my research, and I decided to interpret it broadly as research in some areas related to what I've worked in. That's what's driving this presentation. At the same time, I will give caveats. This is not a representative sample of all knowledge. I'm going to focus on research that I've been involved in that related to stuff I've done, because that was an invitation that originally led to the synthesis. I'm going to focus on the US more than other countries. I will talk mostly about pollution, but I will have very little to say about exhaustible or renewable natural resources, about goods like fisheries and deforestation and groundwater extraction. There's just much less analysis of those resources. There's much more about air and water pollution. Finally, other scholars have written reviews of individual types of pollution. There are excellent reviews of air pollution. There are reviews of water pollution. There are reviews of equity. I'm going to try to put it all together and we'll see what we learn from combining it. So in the rest of this time, I'll go one by one through each of these hypotheses. I'll talk about what exactly the hypothesis means, what the evidence for against it is, and where that evidence comes from. Let me just pause and see if there are any questions so far, if everything is clear before I proceed.
Yes.
So just to be on the same page, these 4 hypotheses are designed to answer or at least provide a potential explanation for the question of what is the main driving factor of the past half century of air pollution.
I would say they're designed to say what are trends in air pollution and water pollution and other resources. So first, just how are they changing?
Mm-hmm.
That's the first hypothesis. Second hypothesis, why are they changing? Is it environmental policy or something else? The third hypothesis, do the benefits of those changes outweigh the costs of the investments we've made? And then the fourth hypothesis, if you go beyond the average, what are the changes in the distribution of the environment between black and white and rich and poor communities? And does that depend on what policies have caused them?
Okay, thank you.
Sure, thanks. Any other questions at the outset? Okay, great, let's forge ahead. So I'm first going to talk about trends in pollution. And I'm going to start with air pollution. These trends are the easiest to measure. This is from a paper published by Janet Curry at Princeton and Reid Walker here at Berkeley. They took 4 widely measured types of air pollution and used a set of ambient air quality monitors to measure their trends over the last few decades. And for each of these pollutants, there have been quite dramatic, steady and continuous declines. Carbon monoxide has fallen more than 80%. A lot of this comes from transportation and oil refining. But then pollutants that come from power plants and industrial activity like nitrogen oxides and particulate matter, these are also falling substantially. I will note that since this paper was published in the last few years, particulate matter has somewhat steadied and in the Western US even increased, but that's clearly because of wildfires. Most of these patterns are reflecting transportation, industry, and household heating. So I think there's no debate air pollution is getting better. Pollution in rivers and lakes is harder to measure. Colleague Dave Kaiser and I have written a series of papers where we've used 50 million pollution readings across the country over the last half century. And we've looked at many measures of pollution, but one that's simple to interpret is to ask what share of rivers and lakes are safe for fishing. They have low enough levels that they don't violate prevailing standards to be safe for fishing or swimming or boating. Here I'm showing the opposite. What share of waters are unsafe? These blue dots show the year-by-year values from these 50 million readings, and this red dashed lines show confidence regions. You can generally see the share of waters that are unsafe has fallen substantially and steadily. About 28% of waters were unsafe at the time the Clean Water Act was passed in 1972, and now it's closer to 15%. So water quality has gotten better, surface water pollution has gotten down. Drinking water pollution is separate. So you can have pollution in rivers or lakes, but we purify it before it gets to your kitchen tap. This is from a paper in the Proceedings of the National Academy of Sciences that asks, what has happened to pollution in the water we drink? What share of that water is violating the Safe Drinking Water Act? This graph, you'll notice, does not look like a downward trend. And the reason is this is just asking in each year, what share of drinking water systems violate the Safe Drinking Water Act? And in years with these vertical red lines, the Safe Drinking Water Act was changed and a new rule was rolled out that tightened standards. And so you see each time standards tighten, rates of violations go way up. And then over about a decade, systems learn how to comply, they decrease pollution, but then standards tighten again, the violations go up. This doesn't mean necessarily that pollution goes up, it just means that the standards got more stringent. And so even if pollution didn't change, more systems were out of compliance. And then once the new rule gets implemented, systems gradually comply. And so my cautious interpretation of this is that drinking water pollution is going down, but standards are tightening. I will tell you, I've been doing other research on drinking water pollution, which clearly bears out that pattern and shows that pollution in the water people drink coming through your kitchen tap is going down. It's not perfect, still 10 to 20% of people drinking water that violates the Safe Drinking Water Act, but that share has been decreasing over time. So that's water pollution and air pollution, those are going down. Now let's look at greenhouse gas emissions. And here the story is not quite as rosy. Over the last half century, greenhouse gas emissions from the US have been rising. This graph just shows carbon dioxide emissions, but looking at other greenhouse gases like methane shows a similar pattern. There is a decrease towards the end of this graph, which has two causes. One was the 2008 recession, you can see quite abruptly, and the other is hydraulic fracturing, by which natural gas has displaced coal and US energy demand. So this pattern has somewhat flattened and decreased recently, and the Inflation Reduction Act is going to lead to even more of a decrease. But over the last half century, this pattern looks extremely different than air and water pollution. It's a pattern of increases, not decreases. Finally, there is more speculative data on toxic air pollution coming from industries. These are nasty cancer-causing compounds like benzene and toluene. These are more difficult to measure. They're self-reported, but any way you cut the data also suggests that releases of these toxic pollution to the ground, to air, and to water have all been decreasing. That's what all these decreasing lines show. And finally, I wanted to show just one picture of natural resources. This is a picture of trends in groundwater. So how much water is there in aquifers underground across the country? This is measured from a pair of satellites called GRACE that use gravitational pull from underground water to measure trends. And you see a mixed picture. The Central Valley Aquifer in California is declining. Many parts of the Ogallala Aquifer in the High Plains are running out of water. Drought has decreased groundwater supplies in the mid-Atlantic and southern US, but at the same time, abundant water supplies and limited extraction have increased groundwater in the upper Midwest. So this is just one picture for natural resources that says in some areas they're becoming more abundant, in others we're exhausting. So let me synthesize what I would say about this first hypothesis. I think there's decent and maybe pretty strong evidence that air pollution, drinking water pollution, and surface water pollution are declining, and that greenhouse gases do not have that same trend. There's a lot of types of pollution that I have not looked at in detail: radioactivity, noise. I only showed you pollutants that the Safe Drinking Water Act regulates. There are many unregulated pollutants. But it's interesting to think about, why would it be that air and water pollution are decreasing and greenhouse gases are not? And one potential reason is that it's very clear if air pollution is bad, you can see it, you can feel it, you can breathe it. It has a very salient effect on local well-being. But if you look at greenhouse gases, those are much harder to see. We have to rely on monitors to tell us what's the level of greenhouse gases. The benefits of slowing down our emissions of greenhouse gases go to the entire world, not just the US, not just the local community. They're much more diffuse. That might make it harder to regulate. But this first part of this talk was just about trends, and I'm now going to transition to look at the second hypothesis and think about what's causing these trends. Is it environmental policy or some other force, like outsourcing dirty production to other countries, or innovation and technological progress? Let me pause for a moment as I switch from the first to the second hypothesis and see, is this all clear so far? Are there any clarifying questions before I go ahead?
So thank you very much. My question is, just to be sure, for the first hypothesis, so it wasn't like you did any statistical analysis, you only reported previous analysis done by other researchers, right?
It's a good question. Like I said at the outset, what I'm presenting here is a review, a synthesis of research that I and others have done. And I'm basically taking the most interesting result from a number of different papers. So for example, this graph is from a paper that I did with Dave Kaiser. It took us 10 years to do this research and collect the 50 million pollution readings. We make numerous adjustments to ensure that this is a representative sample of river and water pollution in the US. And I'd encourage you to look at this research paper. It's on my website. We have another paper. We have two other papers looking at the same kind of question. But here, I'm not going to get into all the analysis. I'm just going to tell you the punchline. I'd love to talk more about the details, but in 1 hour, I can't do it for all these different topics. Does that answer your question?
Yes.
Okay, great. All right, so let me go to the second part of this talk, which is, why is this happening? And my hypothesis is that it's environmental policy primarily causing these trends. Somebody might take it as obvious. They might say, well, of course the Clean Air Act caused this, but you could imagine lots of other patterns. You could imagine this happened because factories moved to Mexico and China, trade and outsourcing moved dirty production elsewhere. Or you could imagine this happened because technological progress means we're more productive every year, and we've just found ways to produce goods without emitting pollution. Maybe this has happened because the US economy has moved from manufacturing to services. Economists sometimes call that structural transformation. Maybe this is happening because people have changed the kind of goods they buy. We used to spend a lot of our resources on cars, and now we're buying technological goods like phones and iPads. Maybe those are cleaner. Or maybe there's a more deep economic explanation that courts have gotten better at allowing people to sue polluters, and therefore communities maybe have better gotten able to persuade local factories to clean up pollution. Those are all possible explanations. And I'm going to review some evidence saying those are not the main reason. Environmental policy is the main reason. And the approach I'm going to use is to look at, in just a couple settings, a very specific policy, and then try to extrapolate and aggregate from that policy to learn broadly about the whole economy, not just about one specific policy. So I'm going to do this in two settings. The first, we'll look at air pollution from manufacturing plants. So this is a paper I wrote with Reed Walker, also at UC Berkeley. We published it in the American Economic Review. And we started with this intriguing pattern. If you look over recent decades, the real value of US manufacturing output has increased. That's what this blue line shows. We normalize that value to equal 100 in the year 1990. Real output's gone up by about a third between 1990 and 2008. And a lot of people think manufacturing in the US is declining or shrinking. It is true that manufacturing employment has declined, but manufacturing production has increased. That's because manufacturing has gotten more productive and more productive in labor, so they hire fewer workers, they produce more stuff. But what's intriguing is that pollution emissions from manufacturing have fallen. Each of these dashed lines shows a different type of air pollution. They each have an abbreviation: carbon monoxide, nitrogen oxides, particulate matter, sulfur dioxide, volatile organic compounds. They've all fallen by more than 50% over this time period. So there's something that's happened to the US manufacturing sector that's made it possible to produce more output, but at the same time to emit less pollution. In this analysis, this paper we published tries to think about why it is that's happening. Is it because we're outsourcing dirty goods to other countries? Is it because we're consuming different kinds of goods? Is it because technological progress has let us change the way we produce goods, or is it because of environmental policy? I'm going to spare you the details of exactly how we do this. I will tell you, we design a mathematical model that says firms are maximizing profits, they face environmental policy, they face competition from trade, and they have to decide what to produce and how much to clean up pollution. And we use that along with data on pollution emissions from each firm, production and trade data for each firm, to back out a few interesting pieces of information for the entire economy. The first thing we back out is to figure out what is essentially the price on pollution that firms face. Now, the US doesn't literally have a price on pollution. We don't have pollution taxes. Instead, we have dozens of policies that are regulations and cap and trade markets and standards. There are many other environmental policies that firms face, but we use all these data and this pretty typical model that economists build of firms to say, look, we see firms are decreasing pollution emissions. We see how much they spend cleaning up pollution. Let's use that to back out, if there were a pollution tax that explains that their behavior, what's the rate of that pollution tax? In other words, in percentage terms, how much more stringent has environmental regulation become? And if we normalize the stringency of environmental policy to the value 100 in the year 1990, this says that in real terms over this time period, environmental regulation has become about twice as stringent. These numbers go up to about 200. The solid line is for dirty industries. The dashed line is for clean manufacturing industries. So just to express this fact another way, this says, if all environmental policy was a tax, so every time a factory emits a pound of pollution, they have to pay $1, how did that tax rate change? And this says that it doubled over this time period. When we then use this model to say, I know this graph, by the way, I know this looks like spaghetti thrown on the wall, but just bear with me, I'm going to try to explain it. So we said, let's look over this time period and say, how much did pollution actually decrease? That's the solid blue line. And then how much would pollution have decreased if we look one at a time at the different forces affecting pollution? So the line with red squares says what would have happened to pollution from US manufacturing if environmental regulation tightened in the way it actually did, but there had been no change in trade, no change in competition from Mexico and China, no change in innovation, no change in the share of our spending on different goods. What happened if over these 18 years, literally the only thing that changed was environmental policy? That's what the dashed line with these red squares says. And you can see this dashed line is very close to the solid blue line. That means over this time period, if nothing else but environmental regulation had changed, pollution would have fallen by more than half from manufacturing. And these other dashed lines that also look like spaghetti thrown on the wall, these say what would have happened to pollution emissions from manufacturing if competition from foreign countries had changed, or if the share of spending on different goods had changed, or if US innovation and productivity had changed. And you can see none of these lead to a very substantial decrease in pollution. In some years, some of these forces would have moderately increased pollution, some would have decreased. But if you ask which of these channels completely accounts for the decrease in pollution, it's the fact that regulation of the environment got more stringent. It was the Clean Air Act. It was not NAFTA. It was not China joining the WTO. It was not research and development. The second set I'm going to look at is looking at air pollution from passenger vehicles. And I just published a paper with 3 co-authors, Mark Jacobson from UC San Diego, Jim Salee from UC Berkeley, and Arthur Van Ventham from the University of Pennsylvania Wharton School. We collected data on the pollution emissions from essentially every new car that's been sold in the US in the last half century. And we have reasonably good data on cars sold in the 1950s and 60s. So this graph says for the average car sold in the US when it was new, how many grams of pollution did it emit for each mile that was driven? This is a logarithmic scale. Regulation of pollution from passenger vehicles started in 1967. In years before that regulation, there was no trend at all in pollution from vehicles. The average new car that was sold emitted 85 grams of pollution per mile that it was driven. This particular graph, I think, is showing nitrogen oxides pollution emissions, but we look at several different pollutants and these trends look almost identical. So before regulation, there was no trend in pollution from vehicles, even though there was a lot of innovation. Cars were becoming faster and more powerful and had better torque, their pollution didn't change. Literally in the year regulation started, you see this very abrupt decrease in pollution per mile from vehicles. That's continued all the way through. We now have data through model year 2021. You even see it through model year 2021. You can basically ignore these red circles. These are dealing for the fact that different makes and models have different sales levels. And in some years, we could account for that very well. And it turns out that doesn't matter so much. So think of this graph as showing how much pollution comes from the tailpipe of your car when you drive a mile. That amount of pollution fell by 99.5% over this time period. This graph certainly suggests that these regulations started that trend, but we look at that in many different ways. I'll just show you one example. So this graph is looking over a 30-year period, and the graph on the left shows Clean Air Act standards. It is illegal to sell a new vehicle in the US if its emissions exceed these standards. And there, in some years, are different standards for different kinds of cars. So here, these red circles show standards for light-duty trucks. Those include pickup trucks, minivans, and sport utility vehicles. And the blue squares show standards for passenger cars, also called light-duty vehicles. Those are like sedans and hatchbacks. You can see in different years, the standards for light-duty trucks became more stringent. The standards for light-duty vehicles didn't actually change. So this is the law on the left. This is what the Clean Air Act says companies have to do. And then the graph on the right are actual emissions from tests where you hook up a sampler and a computer to the tailpipe of a car and drive it in a sampled sequence. And if you compare these, you see they line up very closely. In 1984, standards tightened for trucks, but not passenger vehicles. And you see pollution fell exactly in that year, exactly for the later regulated group. You see the same thing in the mid-90s. You see the same kind of thing in early 2000s. And this paper we wrote looks across all years, all types of vehicles, all standards, and finds when standards tighten, pollution emissions of vehicles fall substantially. We see that in official new car tests. We see it in smog check inspection tests of used vehicles. We see it in remote sensing roadside tests, where some states have these infrared ultraviolet beams that they put on the side of highways and roads. They take an image of the exhaust plume that appears after a car drives by, and they use sophisticated technology to measure the amount of pollution a vehicle emits just by looking at its exhaust plume. Then they take a photo of the license plate and they link that pollution to the car's characteristics. And that's one way to get away from the kind of cheating that Volkswagen got in trouble for a few years ago with its defeat device. All of those data lead to the same conclusion. There's been a 99.5% decrease in pollution per mile for US passenger vehicles. And the vast majority of that is because of Clean Air Act standards, not because of other causes. I just told you about air pollution. I could talk about, has regulation affected river and lake pollution or drinking water pollution? I'm not going to for time, but I will tell you that I and others have done research on how environmental policy has affected pollution in these other domains. And it tends to have a similar conclusion, which is that the most important driver of those trends that I talked about in the first hypothesis has been environmental policy. Doesn't mean that trade doesn't matter or that innovation doesn't matter. Certainly they do. They're just much less quantitatively important than environmental policy. So that's the second hypothesis. I think a question somebody asked at the outset was, what's the research question of your paper? And I said there's 4. What are trends? That's the first hypothesis. Why are they happening? That's the second hypothesis. Do they pass a cost-benefit test? That's what I'm about to tell you. And then what's their impact on equality? Let me just pause again and see if there's any clarifying questions before I go to the third part, which talks about costs and benefits. Stunned silence. Okay, great. Let's forge ahead. Oh, one question. Great.
Actually, it's more a comment because I live with a fellow who was really involved in that engine development and getting the probe up the tailpipe implemented around the country.
That's
And
great.
he said, okay, we've fixed this to 99%. And so what he then went on to do was to start working on the fuels. So now
Yeah.
my plug is one of the last ones of today. I'm going to be talking about those fuels and
Oh,
how
great.
we take that next bit to decrease some of those pollutants more.
That's a great compliment to this. The only note I'll say on that is I agree with everything you said. One point I did not show you because of time, there's a 100-page paper on my website that goes into a lot of detail on it. But the two graphs I showed you are for new cars. And as cars get older, as you drive your car and it ages, its pollution increases massively over its lifespan. And today, a majority of air pollution from cars is from cars that are more than 10 or 15 years old when these technologies start to break down. And so I think in addition to improving fuels, another challenge today is how do we deal with a large share of pollution coming from somewhat old cars where the catalytic converter is breaking down or it was manufactured under weaker standards, especially because those older, dirtier cars are predominantly owned in low-income communities and communities of color. And so making it more expensive to drive dirty cars has challenging equity implications. And so it's useful to think about how do we deal with pollution from old cars and also what's the incidence of that.
So that's where we come to the renewable fuels and ethanol, where that also displaces things like benzene. And so it's a much cleaner burning fuel. So if you do have an old car, you can also retrofit it to use E85 like we did with my 2002 Ford. So you can use, that's exactly an equity issue that we talk about in our organization a lot.
That's great. Thanks for mentioning that.
Hi. Do you think hydrogen as a fuel has a future on the reduction of pollution in the air?
That's an excellent question. The Inflation Reduction Act has large subsidies for hydrogen centers, and the infrastructure bill did also. I believe that policymakers and engineers see it as an advanced potential new technology, and I don't believe there's a high degree of consensus on how large its potential is. There are some industries where it seems reasonably likely to be effective. For transportation, my sense is that electrification is pretty much the name of the game and seems to be outpacing hydrogen in expectations for what's going to happen in transportation. The only data point I have firsthand is a friend who's a professor at the University of California, Davis, and bought a hydrogen vehicle because there were hydrogen charging stations there. This was a year or two ago, and the technology was still being worked out. And every time he went to the station to put hydrogen in his car, the pump was covered in ice because hydrogen has to be at an extremely cold temperature to work for transportation. And he had to buy this like incredibly heavy duty leather insulated glove every time he wanted to pump the hydrogen into his car so he didn't freeze his hand off. So that's a characteristic of a new technology. It's still getting the bumps worked out, but I don't have a crystal ball to know exactly how that'll work out. Great. So I'm going to go to the third part of this discussion, which is what are the costs and benefits of these investments? Certainly, we would love to have as good an environment as we can, but at some point it becomes prohibitively expensive to clean up pollution from the very last power plant or the very last car or household. I'm going to talk about a research paper I've done in this area with Reed Walker from UC Berkeley, where we looked at a part of the Clean Air Act, which has really not been a focus of research. It's a part that creates 500 local markets for pollution across the US. The Clean Air Act literally calls them emissions reductions credits. That's what ERC is, but I'm just going to call them pollution offsets. So let me explain how these markets work and then what we learned from analyzing them. The Clean Air Act designates certain cities as polluted, technically it calls them non-attainment, and it has a rule that if you live in a polluted city, there cannot be a net increase in pollution emissions from factories. So suppose there's an existing factory A which is in a city and it's emitting 200 tons of pollution per year, it's complying with Clean Air Act requirements. Now, suppose this factory comes up with a way to clean up its pollution. It's going to install a new piece of pollution control technology like a scrubber or something else that will decrease its pollution emissions by 140 tons. So now this existing factory is doing even more than the law requires. It's only emitting 60 tons of pollution, but the Clean Air Act says it could emit 200. It can take these extra tons of pollution and put them in an offset bank, technically called an emission reduction credit bank. Now, literally the bank is just a website that the state or an air district maintains, but it says this factory is doing more than it has to, and they can sell the right to emit pollution to a new factory that would like to open. So now a new factory wants to open in this city. It's going to emit 130 tons of pollution. And the Clean Air Act says it is illegal to increase total pollution emissions from this city. So this new factory has to persuade an existing factory to decrease its pollution. And they do it by paying them. They buy this certificate that says whoever holds this certificate can emit 140 tons of pollution. The existing factory cleaned up that pollution, and the new factory buys their certificate so that it has the right to emit pollution. This kind of trade has been happening all the time since the Clean Air Act. If you want to get into the policy minutia, this is the Policy Studies Organization. This is not literally a cap and trade market. It's similar, but it's technically called an offset market. And the reason, I won't get into the reason, but it's close to a cap and trade market, but it's a little bit different design called an offset market. Here's just one example of one of these trades. This is a screenshot of one of these emissions reductions credit. It was created in a suburb of Houston, Texas called Magnolia, Texas. There's a company called Scanpack Manufacturing, which creates high friction materials used in food services and railroads and metalwork and other industries. And they installed a type of pollution control technology that cleans up pollution. The pollutant we're talking about here is called volatile organic compounds. Those are some chemicals we mentioned earlier, like benzene and toluene. If you're ever pumping gas at the gas station and you smell some nasty smells, that's what this is, volatile organic compounds. So this factory, Scanpack Manufacturing, found a way they could decrease their emissions of this pollutant by 21.8 tons per year. And they literally got this piece of paper from the state regulator in Texas saying, you hereby have the right to sell this to somebody, and that someone else can emit 21.8 tons of pollution. And so they sold this certificate to an oil and gas company later that year. I'm blanking on the name of the company, but they sold it for several $1 million. And that new company built a petrochemical plant that emitted this amount of pollution, and buying this gave them the right to do it. A reason these markets are interesting to study, apart from the fact that they're an important part of the Clean Air Act, is because it has these prices where existing factories are paying incumbent factories to clean up pollution. And the research that we've done looks in detail at those payments and realizes those payments tell you how expensive it is to clean up pollution. If you are an existing plant and you can get $4 million for cleaning up 22 tons of pollution, boy, you sure want to do that if you can find any way to do it for less than $4 million. And if you're a new factory that's opening, you want to clean up pollution as long as it's cheaper than $4 million for these 22 tons. Once it becomes too expensive to clean up pollution, you want to buy one of these certificates instead of installing pollution control technology. And therefore, the prices of these certificates tell us what is the cost to clean up pollution. And that's useful because we can then compare it to the benefits of cleaning up pollution by using research that atmospheric chemists and epidemiologists have done, where they look at pollution emissions from factories in each city. They ask, how does that affect air quality in each city? And then they look at epidemiological studies of how that affects premature mortality. And finally, they use evidence on how people value decreases in premature mortality to measure the benefits of cleaning up pollution. So this graph is showing city by city, what is the cost of cleaning up pollution in thousands of tons per year? Those are the blue dots, as measured by firms' actual engagement in markets to buy and sell pollution, when they buy and sell these offsets I described. So the blue dots show the cost of cleaning up pollution, and the red diamonds show the benefits of cleaning up pollution as measured through improvements in air quality and resulting decreases in premature mortality. And you can see for pretty much each one of these cities, the benefits of cleaning up pollution are enormous compared to the costs. The benefits are more than 10 times the costs of cleaning up pollution. And we found this somewhat surprising because I showed you at the beginning, pollution has decreased enormously in the last few decades. And it tends to be that the more you clean up pollution, the more expensive it is to get the last bit. Once you pick the low-hanging fruit and clean up pollution in the cheapest ways you can, the remaining pollution tends to be very expensive to clean up. And it is true in some of these cities, it costs $10,000 to clean up a ton of pollution, but pollution is so harmful to human health that the benefits are massively larger. And on average, across all of these cities, we measure benefits of cleaning up air pollution that are more than 10 times the costs. So is it efficient? Does it pass a benefit cost analysis to clean up air pollution? This study would say yes. I'm going to compare that against other research I've done on the Clean Water Act. And I spent a lot of time focusing on one part of the Clean Water Act that tries to clean up municipal pollution. So in every city, when you flush a toilet or flush water down a sink, it goes through thousands of miles of underground pipes, and then it's dumped into rivers or lakes or the ocean. But before it's dumped, it goes through what's called a wastewater treatment plant. This is a photo of the wastewater treatment plant in Los Angeles. You can see LAX airport is here in the background. If you're ever taking off from a flight in LAX, look down and you'll see this thing. You might have a Brita water filter in your fridge. This is like a $1 billion version of a Brita. It takes dirty water coming from underground pipes and it cleans it up before that water gets dumped in rivers and lakes and oceans. The Clean Water Act has led to spending of hundreds of billions of dollars to improve these wastewater treatment plants. And so this research I've done wanted to understand what are the benefits of those investments. And we've compared it. So here are all the plants that have received investments. We used a network model of flow across all rivers and streams in the US. This is a beautiful colored map of those streams. We put together 50 million water pollution readings from across the US, and we wanted to know, how did this spending under the Clean Water Act affect water pollution and how people valued it? I think for time, I'm not going to dwell on the change in water pollution, but I'll tell you, we find when the Clean Water Act gives a city money to clean up pollution, it substantially decreases pollution. We then ask, do people care about improvements in water quality in rivers and streams and lakes and oceans? And there's different ways to measure that. Some people look at recreational activity like who goes swimming and fishing and boating. Some people look at health outcomes. We wrote one study that looked at home values, which is a partial measure of people's value. You know, if you have a house on a river that's a toxic waste dump, it smells and looks terrible and fish are dying, you could imagine that if the Clean Water Act cleaned up that river or stream, your home value might increase. So we use population census data to look at the value of all homes near all rivers in the US. We look at tens of thousands of grants the Clean Water Act gave cities to improve water quality. And we ask, how do home values and apartment values change when the Clean Water Act improves water pollution? And we estimate that home values do increase. But if you compare the change in home values against the costs of these Clean Water Act grants that are designed to clean up water pollution, the change in home values is much smaller than the cost of these grants. If you're as inclusive as possible and try to impute all the missing values, we managed to get a ratio of about 0.25. So if the Clean Water Act spends $10 million to clean up water pollution on one river, home prices increase in aggregate by about $2.5 million, by about a quarter of the cost. By this metric alone, there are benefits, but they're smaller than the costs. But of course, you might say, this is missing all kinds of costs. It's missing health. People might not be aware. It's missing recreation. And so we did a review of all the studies we could find that compared the benefits versus the cost of regulations imposed under the Clean Water Act, those are in gray, versus regulations imposed under the Clean Air Act, those are in blue. This graph is showing mostly analysis done by the federal government, but we also reviewed analyses done by academics, independent organizations. And the consistent pattern is that investments to clean up air pollution have extremely large benefits relative to their costs. More than 40% of studies that we reviewed found that air pollution regulations have benefits that are more than 10 times their costs. However, if you look at regulation of rivers and lake pollution, the majority of those studies find benefits that are less than their costs. The estimated benefits fail a benefit cost test. That was true of the one study I just told you about very briefly. It's also true for most of dozens of other studies. In fact, about 75% of papers on the Clean Water Act find that it fails a benefit cost test. And I think that leads to a bit of a conundrum. Does it mean that this is not an efficient investment, that we should reallocate spending from surface water to air pollution or something else? Or does it mean that we're miscounting and undervaluing the benefits of cleaning up water pollution? And I think that's an open question. I started doing research on this about a decade ago, and several of my papers pose this conundrum. And I've been gratified to see that other people are now wrestling with this question. Are we undervaluing the benefits of clean rivers and streams? Or are those investments very expensive and it would be a more efficient use of resources to focus somewhere else? I could tell you about other pollutants. Drinking water tends to pass a benefit cost test, but I think I'm going to sum up and say most analyses of air pollution find enormous benefits relative to costs. Most studies of river and lake pollution don't, and it's still an outstanding question why. Was there a question or comment?
Yes.
Great.
I would like again to share a personal experience. I grew up in Cleveland, Ohio, or in
Okay.
a suburb. Yes, when the Cuyahoga River burned, and literally the boats that came to try to put it out also burned because they were made out of wood.
Yeah.
We had, when in the summertime, we had to listen to the radio to find out what the bacteria counts were at the parks that had places to swim. When you're looking at, right, when you're looking at, and now I can go and I can walk out into the water and see my feet up from my chest. Amazing improvement. And at the same time, when you're looking at the housing prices, that's when it was the Rust Belt, and people just moved down to the Southwest and just left the North Midwest. So your housing prices there are still very low, and the population is very decreased from what it was. And so that measure absolutely does not reflect the benefit that cleaning up that water had for that community.
Thank you for your comment. I'm always interested in the Cuyahoga River because it's so central. I'll just tell you my two favorite anecdotes about it. One is that, did I mention this? The Cuyahoga River lit on fire every decade between 1870 and 1960. And finally, the Clean Water Act stopped it. And in fact, the 1969 fire on the Cuyahoga that people focus on, it was actually put out before a photographer got there. And so Time magazine a few months later ran this expose on the fire in the Cuyahoga, and they ran a photo from the 1953 fire, but they mislabeled it as the 1969 fire. And many politicians in the 1970s say that Time article and that photo galvanized their attention and made them feel that industrialization had gone too far and that they had to do something about it. And then my other favorite tiny factoid is that you might know this Dr. Seuss kids book, The Lorax. A lot of people read to their kids about the environment. The original version of The Lorax made fun of pollution in the Cuyahoga River. It directly referred to it. It had like a rhyme talking about pollution in Ohio. And in the 1980s, after these investments we're talking about that cleaned it up, a group of concerned citizens and kids in Ohio wrote a letter to Dr. Seuss and said, stop trashing our city, we cleaned up the Cuyahoga. And he reissued the Lorax. And now the Lorax doesn't say anything about the Cuyahoga. And you can only find it in like archival ancient versions of the Lorax. And he's only once ever reissued another of his books because of a mistake, although recently there's been some controversy over those other books. We could talk about home values and water pollution a lot. As I said, I spent many years and written a bunch of papers about it. I completely agree. It understates the value that people assign to water quality. I will say, however, many people have spent a lot of effort in a lot of ways to try to measure what's the value of cleaning up rivers and lakes and streams. And they all certainly measure positive values. The challenge is that it's very expensive. It costs tens of millions for some cities or hundreds of billions nationally. And I certainly don't take a conclusion as saying these are bad investments. I just am summarizing a pattern that people seem to find again and again, which is it's difficult to quantify benefits that exceed the costs. And a lot of people are working on it right now. And my hope is that we'll make some progress in the next few years in research. But I find this very surprising. Other people do too. I think the question highlights that it's a surprising pattern. It's different than our expectations, and it's worth figuring out why. Let me briefly talk about equality and environmental justice. I'll talk for about 10 more minutes, and then we could have a roundtable discussion for 10 minutes. I would describe two different classes of environmental policies. So say you want to clean up air pollution or water pollution or greenhouse gases. One way you can do it is creating a market for pollution. That could be a pollution tax. It could be a cap and trade market where you say the whole country can't emit more than 1 billion tons of pollution, but we're going to let firms buy and sell pieces of paper that say whoever has this piece of paper gets to emit 1 ton of pollution. That's a cap and trade market. Or you can have markets that combine pollution taxes and cap and trade markets. For example, the state of California has a cap and trade market for carbon dioxide. It's called the AB 32 market. And that's a hybrid. It's a cap and trade market with a price floor and a ceiling. So it ends up behaving like a pollution tax. Those kind of markets, economists often advocate them because they're cost effective. For a given amount of spending, they minimize the amount of pollution that is emitted. Or put another way, for a given level of environmental quality, they minimize the cost. So they can be much cheaper than pollution standards. But the most common policy is not to use markets. Instead, it's to use what are called command and control policies or pollution standards. So a standard would be where a regulator goes to every factory and says, here is how much pollution you may emit. It's usually the same amount for every factory. And standards like that are popular. People like the idea of telling polluters you have to clean up and telling every polluter to clean up the same way. The reason they are relatively expensive is that typically some factories or power plants have really cheap ways to clean up pollution. They have good managers, they can access clean technology. Other factories, it's very expensive to clean up pollution. And so markets allow the cleanup of pollution to happen at factories that are good at cleaning up pollution where it's cheap, whereas standards require the same reduction from all factories. So that's just a general description of two kinds of policies that regulators can use to clean up pollution. And now let me describe, recently there's been growth of the environmental justice movement, which is concerned that environmental policy should be inclusive. All groups in society should help design it. It should be participatory. Community organizations should have a part. It should respect all groups in society and should treat them fairly. The environmental justice movement, the environmental justice is one of the Biden administration's top 2 environmental concerns alongside climate change. And it is motivated by the observation that environmental quality has very uneven distribution around the country. Low-income communities and communities of color tend to have much higher pollution levels, and the environmental justice movement wants to fix that. So there are 2 ideas here. Policy choice, markets versus standards. Second idea is environmental justice. In this part of the talk, I want to talk about how those 2 ideas are related, because in several instances, there's been concern that markets are bad for environmental justice, that environmental markets are unequal. For example, Washington voted on a state ballot measure to create a carbon tax, and liberal environmental justice groups opposed it, which is surprising. Usually liberal groups support environmental policy, and they opposed it out of concern that it might have adverse effects for equity. Similarly, California has a cap and trade market. I mentioned AB 32. It's supposed to be renewed in the year 2030, and current hints are that it might not be renewed, primarily out of concern for environmental justice. And a final example, the former head of California's Air Resources Board, Mary Nichols, was discussed as a possible head for the Environmental Protection Agency under the Biden administration. That didn't happen. And there were a number of news articles, including the New York Times, saying it was because she supported this cap and trade bill that environmental justice groups opposed. So this is the motivation for this part of the paper. I wanted to look at recent studies to say, let's look at policies that are standards and environmental policies that are markets and see what's their effect on different groups in society, on Black versus white communities, on rich versus poor communities. There are several papers looking at this question. I'm just mentioning a few of the citations here. They really have mixed evidence. They look at different environmental policies. Some of them are moderately better. In some of them, markets are moderately better for low-income communities and communities of color. In some of the markets are a little bit worse. I'll just show you one set of pictures from an analysis I did with Reed Walker. I told you a bit about these offset markets where I showed you the picture of the certificate, these markets where there are 500 markets around the country. when a new polluting factory opens in a city, they have to pay an existing factory to decrease their pollution. And that is a market that moves pollution from existing factories to new entrants. And we wanted to say, where is it moving pollution? Is it moving from predominantly Black to predominantly white communities, or from poor communities to rich communities? Where is pollution moving when these trades happen? And so we looked at all the trades where we could get data across the country, and we looked at the demographics of the community where the plants are located that were emitting pollution or that were opening and going to emit pollution. And we said, what is the share of each community that identifies as Black in the population census? We also did graphs like this for Hispanic and low income and other demographics. This graph shows two density plots. So what share of each community has a Black population, which is less than 10% of the whole community, 10 to 20%, 10 to 30%, et cetera. The solid line is factories that are opening, emitting more pollution. The dashed blue line is factories that are cleaning up pollution. And so you kind of want to look at this graph and say, is one of these very different from the other? Does it look like these markets are moving pollution between Black and white communities? The answer is that there's not much systematic difference. These vertical lines show the average. Basically, these markets are moving pollution from communities where about 15% of the population is Black, and they're moving pollution to communities where about 15% of the population is Black. Now, it's certainly true that there's an unequal distribution of pollution to start with, and one could discuss policies and ask how much these policies are able to change that. But this is just saying these markets don't change the distribution of pollution. You might call that a failure and say, look, I think the goal of these policies should have been to equalize pollution, and they didn't. On the other hand, you might call this as saying the goal of this thing was not to redistribute pollution, it was just to ensure the level of pollution in the city didn't change. It didn't change the level, and it didn't change the distribution. We also look at patterns like this for household income, for poverty and Hispanic rates. And I'll tell you, our broad review from looking at this market and other studies is that you do not find systematic differences between environmental standards and environmental markets as to how they change the distribution of pollution between rich and poor or Black and white communities. There is an unequal distribution to start with, and these policies don't tend to change it unless you design specific components that change that. Again, you could see that as a failure and saying we do or don't want policies that redistribute pollution, or you could see it as benign and saying it's fine to have pollution policies that redistribute pollution, but it doesn't matter if you do it with markets or standards. I would say the evidence on this fourth point is the most limited. The studies I mentioned are very recent. They just look at a handful of markets. This is a hypothesis I'm putting forward, and more evidence is accumulating as people start to see that this is an important question that benefits from more analysis. So I'm just going to restate some of what I've told you. This discussion has covered 4 hypotheses describing the US environment and policy in the last half century. The first hypothesis is that air and water pollution are falling, but greenhouse gases are not. The second is that environmental policies are the main cause. The third hypothesis are that the benefits from cleaning up air and drinking water pollution are quite large relative to the costs. That conclusion is somewhat unclear for river and lake pollution. It's not that the benefits don't exist, it's that researchers have struggled to measure benefits that are commensurate with the costs. That includes analysts in the government, the Environmental Protection Agency, academics, and independent organizations. And finally, the fourth hypothesis is that environmental markets and environmental standards do not have dramatically different incidents across social groups. In this review, I've tried to hint at some advances that have made recent research in this area possible, using extraordinarily rich data that was collected to administer programs that now we can use to analyze them, measuring costs and benefits from within a single setting, looking at components of these laws that until recently have not been a focus of research, using more sophisticated analysis of how pollution moves across geography, looking at microeconomic data and then aggregating to the whole economy, and finally looking at the distributions of environmental quality. Finally, I'm just going to sum up with 2 interesting questions I think are open for analysis. One is, what happens if you look at exhaustible resources like groundwater or timber, deforestation, or fisheries? Do you reach similar conclusions? And finally, why is it that greenhouse gases have such different patterns than pollution? So I'm going to stop here. I'm going to stop screen sharing, and I'd love to discuss any questions or comments people have in the remaining 10 minutes.
Thank you for your presentation. Given the public support for such things as cleaning the Hudson River, the Anacostia River, Rock Creek Park, might shadow pricing just overwhelmingly say how beneficial cleaning the water is, and that should be, if it isn't being looked at?
That's a good question. So the question is, people support investments in clean water. Doesn't that mean it's a good idea? My goal is not to say that this passes or doesn't pass a benefit cost test. It's to say, if we've actually spent more money cleaning up river pollution than we have spent cleaning up air pollution. And every analysis finds particulate matter air pollution is catastrophically bad for human health. The prevailing estimates are about 5% of US deaths occur due to air pollution. And it's been a real struggle to measure commensurate benefits for water pollution. You know, one potential explanation people have put forward is that the Clean Air Act really targets the most polluted communities in urban cities, whereas the Clean Water Act is very purposeful in not targeting those iconic central rivers. It allocates its money very evenly across geography. And it's quite plausible that spending tens of millions of dollars to clean up a river with no people near it has lower net benefits than spending all of those resources to clean up rivers where there are many people. So I don't mean to undercut benefits that people perceive that are real from investing in cleaning up many rivers or specific rivers. I'm just putting forward a pattern that many people have found in analyzing water, which is that if you look at broad investments in water, we're not finding benefits commensurate with the costs. Maybe we're missing them. I and other researchers in the Environmental Protection Agency are spending a lot of effort trying to figure out what is it that we're missing. But I will tell you, by contrast, when you look at drinking water and air pollution, people find enormous benefits relative to costs. So it's a quite striking contrast.
Thank you.
Great. Do people have any other questions or comments?
Yes.
Could you elaborate on what it was that you were discussing about the argument for environmental justice, environmental justice being hurt by market-based solutions to reducing pollution, because that's an aspect of pollution reduction that I'm not quite familiar with.
Thanks. I think it's a very recent topic of discussion, and my sense is not that it is a evidence-centered argument. My sense, so the reason I brought it forward is that there have been several recent prominent policy debates where liberal and environmental justice organizations strongly opposed market-based environmental policies. They opposed cap and trade markets that existed and said, let's get rid of this. And the stated reason is that they thought they had the view, and they still do, that these market-based policies were bad for environmental justice. So that's just a fact describing political support for policy. You could then ask, why is it that those groups have opposed these markets? Why has that happened? I think you might hear a few reasons. I think one of them, so my sense from being an outsider to those specific policy debates, I think a lot of environmental justice organizations have the view the goal of environmental policy needs to be cleaning up pollution in low-income communities and communities of color. And so decreasing pollution nationally or across the state or saving money should not be the goals, is my sense of these conversations. And so when policymakers say, here's a policy that will decrease pollution by 5% across the whole state, or here's a policy that will save 30% of costs and not change pollution, if the objective of environmental policy is to decrease community pollution in low-income communities and communities of color, you would say that's not achieving this objective. And often the response to those markets is to say, instead of the market, you need to pick the 5 power plants that are polluting our community and add pollution control technology on those. So my sense is that's the genesis of the political concern. But it has led to quantification, which asks, is the issue that we're using markets instead of standards? Or is the issue that we're trying to decrease pollution overall and we're not targeting particular communities? So that's the background of that comparison I was giving. Does that clarify at all? Does that answer your question?
Yes, it does.
After I published the article I talked about, there was a Wall Street Journal article by Greg Ip pointing out it is challenging for liberal political groups who support environmental policy, because for the first time, they're very divided, because wanting environmental quality through some market-based instruments now inspires opposition from traditionally liberal organizations, and policymakers and politicians have to figure out how to bridge those concerns between liberal environmental groups that want to clean up pollution, but might not want to use markets or may, and then liberal environmental justice groups that are, many of them, concerned about market-based environmental policies. And so you end up with compromises like the Inflation Reduction Act does not use market-based instruments. It uses subsidies and standards. This could be one contributor.
Thank you. And I did have another question regarding what you were discussing earlier when you were mentioning the idea that for some industries, it is inefficient for them to, or it's inefficient for the same standards to be applied across different an industry, because some companies and some specific with some technology, sometimes it's more expensive for them compared to other ones. Could you repeat some of I thought you had discussed some of the ways to kind of make it that, to kind of even that out to, or, could you just elaborate on that, I guess?
Absolutely. So I'm an economist, I have a PhD in economics, and so that's the perspective I bring to think about environmental policy. And the way economists usually talk about cleaning up pollution is that pollution comes from many sources. There's hundreds of coal-fired power plant units in the US. There are tens of millions of cars. There are thousands of polluting factories. And at some of those, it's fairly easy to clean up pollution. So let's just talk about power plants. Some power plants might be able to buy low sulfur coal. That would decrease their pollution emissions. Some power plants might have a design where it's really easy to add a scrubber. That would clean up their pollution emissions. And then other power plants, they can't access low sulfur coal. Their design makes it really hard to install pollution control technologies like scrubbers. And so at some power plants, it's very expensive to clean up pollution. Economists would call that differences in marginal abatement costs. What is the cost to decrease pollution by 1 pound from different power plants? A standard, also called command and control, will go to every power plant and say every power plant has to reduce pollution. And that tends to be expensive because at some power plants, it's cheap to clean up pollution, and they do the cleanup. But at some power plants, it's very expensive to clean up pollution, and a standard will also require cleanups at the places where it's expensive to clean up pollution. A reason why pollution taxes and cap and trade markets are cost effective, in other words, they decrease pollution the most for a given amount of cost. The reason those market-based policies are cost effective, it's that the pollution cleanup happens where it's cheap. The power plants that have these cheap opportunities to clean up pollution, they say, great, I'm going to clean up pollution. Other people are going to pay me. The plants where it's expensive to clean up pollution, they don't clean up pollution, but they pay taxes or they buy cap and trade allowances. And so market-based instruments allocate the decrease in pollution to the sources where it's cheap to clean up. And standards require a cleanup of pollution from every source, and that's why they tend to be more expensive. Does that answer your question? Does that clarify?
Yes, absolutely. Thank you.
Great. Great. I think we have 1 minute left if there's a last question. Okay, great. Thanks for joining and for your time. Sorry again, I can't be there in person, but it's been nice talking with you and I enjoyed your questions.
Thank you.
Great. Thank you. Enjoy the rest of the conference. Bye, everybody.